Many chemical reactions involve electrons being moved from one molecule, ion, or atom to another. A chemical reaction in which an atom, ion, or molecule gains electrons is a reduction reaction. For example, copper 2 plus 2 electrons going to copper. The part that gains the electrons is said to be reduced, so in this equation the copper 2 plus ions are reduced. A chemical reaction in which an atom, ion, or molecule loses electrons is an oxidation reaction. For example, zinc going to zinc 2 plus 2 electrons. The part that loses the electrons is said to be oxidized, so in this equation the zinc atoms are oxidized. Let's assume these reactions are happening at the same time, so we will add these equations together. We have 2 electrons on both sides, so we can ignore these. What we end up with is a redox reaction. Red from reduction, ox from oxidation. Redox. Reactions for which only the reduction or oxidation is shown are known as ion-electron equations because they involve an ion and electrons. In an oxidation reaction, the electrons are on the right-hand side of the equation. The electrons are lost from the reactants. Oxidation is loss of electrons. In a reduction reaction, the electrons are on the left-hand side of the equation. The reactants gain electrons. Reduction is gain of electrons. The mnemonic often used to remember this is oil rig. Oxidation is loss, reduction is gain. It's important to note that reduction reactions and oxidation reactions always happen simultaneously, that is, at the same time. If a reduction is happening, then an oxidation must also be happening. Similarly, if an oxidation is happening, a reduction must be happening. An agent is something that acts on something else. In a redox reaction, a reducing agent reduces something, that is, it gives electrons to it. In our example, the zinc gives electrons to the copper, so the zinc is the reducing agent. Note that in giving electrons to something else, the reducing agent loses those electrons. The reducing agent is actually oxidized. Similarly, an oxidizing agent oxidizes something else, that is, it takes electrons from it. In our example, the copper 2 plus ions are the oxidizing agent, and it follows that an oxidizing agent must itself gain those electrons, so an oxidizing agent is itself reduced. An oxidizing agent must be able to accept electrons easily. A good reducing agent must give up electrons easily. Non-metal elements in the top right corner of the periodic table have electrons arrangements that are 1 or 2 electrons short of a noble gas arrangement. These elements want to gain electrons and often act as oxidizing agents. Conversely, elements in the first group of the periodic table need to lose just 1 electron to get a full outer shell, and so will give up that electron easily. Therefore, they are good reducing agents. Electronegativity measures the tendency of an atom to attract electrons. The higher the value, the more likely that atom will attract electrons and hence be a good oxidizing agent. Elements in the top right of the periodic table, excluding the noble gases, have high electronegativity values and are good oxidizing agents. Electrons towards the bottom left of the periodic table have low electronegativity values and are good reducing agents. You can find electronegativities for elements on page 11 of your data book.